Awesome. So on this other part, we are looking at volume elasticity. Maybe let me ask Eunice. Eunice, what is volume? What do you understand by the word volume? Yes, Eunice.
Oh, yes, sir.
What do you understand by the word volume?
The amount of space occupied by the substance.
Awesome. That is correct. So the space occupied by that object is what we're talking about, volume. So we're talking about a space in terms of its height, its length, and its width. All that, when you compute it, you get its volume. So, excuse me. And so when we talk about volume elasticity, we're saying this occurs when for example, usually volume elasticity would require forces coming from all sides. All right. So forces coming from all sides, forces coming from the bottom, coming from the top, from all sides, trying to compress the object, right? Trying to squeeze the object. Probably if it was larger, trying to make it smaller. That is what we talk about when we talk about, that is what we mean when we talk about volume elasticity. So, so usually this volume elasticity is experienced when an object is immersed in a fluid. All right. I'm sure we'll be able to talk about buoyancy, forces due to height, pressure due to height at some point. I'm sure, I know we talked about it with the larger group, with the larger PCM-NS group. But yeah, what we are talking about here on volume elasticity is that when an object is immersed in a fluid, what happens is that when you immerse that object at a certain depth, there will be some pressure due to the height of that depth, or should I say due to the depth, because you have immersed that object in a fluid, that fluid will exert some force on that object from all sides, from down, from on top, from all sides, to try and compress that object. All right. So you're saying an object, the shape and type of the shape of this type of object will go unchanged. So if it was a ball, if it was a sphere, it will remain a sphere. If it was a rectangle, it will remain a rectangle. Its shape will remain, but it is probably going to be, its size will be reduced. The volume will change, right? So the volume, so in this case, we no longer talk about just, we have been talking about stress, all right? So in this case, we are now adding a new name to stress. We have been talking about shearing stress, tensile stress, but in this case now we introduce the concept of pressure, all right? So it is the same thing, force over area, but in this case, it is just no longer force, it is the change in that force. So if I was applying a 5 Newton force earlier on an object, if I increase that 5 Newton to, for example, 20 Newtons, that change in the force divided by that surface where I'm exerting that force is what we are now talking about as the pressure. And this it's actually changing pressure, because in volume elasticity, we just don't talk about pressure. So when we are given pressure, we just don't use it and start calculating. We have to look at a change. Sometimes it may be coming from a place where there is zero pressure to a place where there is a certain pressure given. So it will always be talking about change in pressure. You apply a certain change if you change the pressure which is being exerted on a certain surface area, you cause volume stress. And then when we talk about volume strain as well, our volume strain now, it is the change in volume divided by the initial volume. So even here on volume elasticity, we're talking about volume strain, meaning how much has been changed, and usually the change is negative. So you may find that you had a bigger volume and you have reduced your volume when you compress an object, and as you see in our formulas, we will apply a negative to that. So now there is another interesting constant of proportionality, just like the way we've been talking about this. All right. Constant of proportionality in this case is bulk modulus. Have you seen here? Bulk modulus. All right. So let's just see if people are following. All right. So let's see if people are following. Precious.
Yes.
What is the constant of proportionality when we talk about tensile stress? Tensile stress. What is the constant
Tensile. I think it's Young modulus.
Awesome. So we have to be able to keep these things in mind, and maybe let's ask Simbarashe. Simbarashe, are you with us?
Yes, sir.
Yes, Simbarashe. What is the constant of proportionality when we talk about shearing stress? Shearing stress.
Shear modulus.
Awesome. So these things should be on your fingertips. Yeah. And you know, with physics, it is so interesting and elegant in that even if we look at it to be complex, I think I don't even enjoy mathematics as well as much as I enjoy physics, because physics, the mathematics that I apply in physics makes sense. All right. If, for example, someone just tells me differentiate, integrate, I don't even know what it is doing. But here I'm able to calculate physical things that are actually happening in the physical world. An object is thrown at some height and it's falling. You can visualize that. Can you visualize integration? I mean, you can't visualize integration, right? You can't visualize differentiation. You can't. But if you give it some, the mathematics, you give it some physics, it is easy for you to even apply it and see it. And you shouldn't forget these things, because these things are physical. You interact with them in real life. So even when we talk about volume elasticity, you can imagine who has ever gone swimming. I think I can also talk about it and ask you, anyone who has ever gone swimming?
I have.
Okay, so that is Mr. Wisdom. Yeah.
Yes.
Awesome. So what you realize is that when you have gone swimming, if you dive at a very high depth, if you go on a deep part of the river, you experience some pressure on your head, sometimes even your head will start paining. You will just feel like some compression is happening to your head, especially if you go very deep, you will feel that. And that is exactly what we are talking about. In fact, if you go very, very deep, your head will be compressed. It will change some volume. All right. So if you want also to try another formula, get a balloon, fill it with some air, go on a very, very, deep part of the river. You will discover that that balloon will shrink. It will not have the same capacity, or it will not have the same volume it had on the surface. So what we are talking about, all that is volume elasticity. We expect that when we apply pressure, by pressure we mean force over area, all right, the change in force over area. When we apply some pressure, usually it happens in a liquid, in a fluid. When we apply when we change the pressure of an object, we get to change its volume, and the change is negative. The change is negative is because it was big, now it has become small. So we put a negative in advance to account for that negative. So sometimes, yeah, we do that in physics so that we don't have to find negative answers and whatnot. Sometimes we put a negative in advance. So let us have Simbarashe to help us read this question which we have here, so that let's look at an example to help us cement what we have looked at so far. Simbarashe, could you read this question?
Right. So a solid lead sphere of volume 0.5 meters cubed is dropped in the ocean, sinks to a depth of 2 times 10 to the power 3, about 1 mile, where the pressure is increased by 2 times 7 to the power 10 pascals. Lead has bulk modulus of 4.2 times 10 to the power 10 pascals. What is the change in volume of the sphere?
Awesome. So as simple as that, really, a question comes in an exam. You have been given the volume of an object dropped in an ocean to a certain depth, and then you have not even been told to say calculate the pressure at that depth. They have even given you the pressure at that depth to say the change in pressure is that much. Sometimes it may not always be as simple as this, but in this case it has just been given to you simple like that. So for the sake of us just appreciating this concept, let's go in and just look at the data. We have the data, the volume. We have been told the change in pressure, bulk in modulus. All we need to do is just find the change in volume, and it's so simple like that. So since we have a question like that, how can we go about solving it? We see that we know that the change in pressure is equals to the bulk modulus, which is the proportionality constant, bulk modulus multiplied by the change in volume over the initial volume. And if we want the initial volume, we just make it this. If we want a change in volume, we just make the change in volume our subject of the formula. And change in volume becomes volumes times the change in pressure over the bulk modulus. And this is what we have here. And we can find the change in volume. It's a negative change. Why is it a negative change? Because we expect that the volume reduced. All right. Sometimes they will even tell you find the final volume. So the final volume will be this change in volume plus the initial volume, right? So for example, if it had the initial volume was 0.5 cubic meters. If this is the change in volume, all right, meaning This is how much it has reduced by volume. To get the final volume, we'll just have to subtract, to do 0.5 minus this number here. It's already having a minus, so 0.5 plus this negative number will get the final volume. But in this case, they were just telling us to say, find the change in volume. So have you seen how easy it is to go about physics and in just going about dealing with questions and solving them, talking about properties of matter, mechanical properties of matter? Have you seen how easy it is? Are we following? Are we together so far?
Yes, sir.
Yes, sir.
Awesome, awesome. So, of course, sometimes problems in physics, they become a bit complicated.
Yes.
Are you saying yes to the complication or yes to saying we are following? Okay. Yeah, one of our friends said yes. So, but I think one thing that I would just like to say is that questions in physics tend to be a bit complicated sometimes. But the thing is, stick to the principles that you have learned. All right. You know the formulas, you know the principles. So there was a certain question, which I gave you in that test. It was talking about someone, is it a hot air balloon is moving up at a velocity of 8 meters per second, all right? Something is moving up at 8 meters per second. Then at a certain height, is it 12.5 or so? Someone drops that ball, all right? What would be the time it would take to reach the ground? I see some of you guys were having challenges in solving that. I know it's not part of this concept, but I just want to make a point when it comes to physics. What you are supposed to do with such a question, you've been given that an object, someone is going up at 8 meters per second. So you already know that the velocity is a positive because it's going up at 8 meters per second. And then they let go of that object. When they let go of that object will not just fall down. No, it will try to go up a bit because you who is in that object, who is in that maybe in a hot air balloon moving up at 8 meters per second, even the same ball that you're having in your hands is also moving at 8 meters per second. So everything in that hot air balloon is moving at the same velocity. So the velocity you have, even the ball that you have in your hands, you are all moving at the same velocity. So even if you let go of that ball will just not start dropping down. It will try to continue going up until gravity pulls it to the ground. All right. So what you are supposed to do is just put your velocity as positive, your initial velocity as positive, and your displacement, your change in length, your y displacement should be a negative because you expect the ball to fall to the ground. So you put your negative, the height that it was given at somewhere 12.5 or so. You know that the ball will hit the ground at the last point. So you expect your displacement to be a negative. And I don't know how many times I'm going to say this. Acceleration due to gravity is always negative. Whether an object is going up or it's going down, in your calculations, whenever you encounter G, acceleration due to gravity is always negative. All right, some of you guys were solving, you put a positive. 9.8, you write it positive. I don't know how many times I have to say this. So in all your calculations, you have to put a positive. Sometimes sometimes when you are solving quadratic equations, some people asking me, when you are solving quadratic time in quadratic equations, which time are you supposed to put? Because in quadratic formula, it says plus or minus. I explained that usually time you get a plus one. You get a plus one. Usually that's what we do. We get a plus one. I know there was a certain question which was asking, saying which two times will the ball reach at? Is it a height of 29 meters there? Of course, that's when now you are supposed to use both the plus minus. So you can use the minus part and the plus part, because you are talking about when the object will be rising up, that will be positive, and when the object will be falling down, that will be negative. So that's when now you get to use both the plus and minus. Are you following, friends?
Yes, sir.
Yes, sir.
Yes.
Now, sir,
Mm-hmm.
just a question from there.
Yes.
Yeah, when using both times, negative plus or minus time, are you supposed to indicate the negative, or you just ignore the negative because the time never be negative?
Yes.
That's what you say.
So you find that when you have been told, for example, in that question which we were told to say find the two times, you will not find a case where time will be negative. Even if you use the plus and minus, you find that in both cases time will be positive. It will always be positive. So, but when you have not been taught to find the two times, you have been just said find time, you get the positive one. Don't use the plus and minus, just get the plus.
All right.
Awesome. So this is where we have come to the end of our class today. And before this video just becomes too long. So the homework which I'm saying is that, again, I said it last time to say, solve the questions in the tour sheet on this topic and then submit to me. So I'm saying it again, solve all the questions in the tour sheet on this, it should be tutorial sheet 9 or so, and then submit to me, okay? And so we are saying tomorrow we can have a quiz, just one question or so, at 10 hours, the same 10 hours. Let's see. Maybe we'll have it at, okay, we'll have the quiz, yes, at 10 hours. And then, so that I can just see how much you're understanding these concepts. But otherwise, solve all the questions which are there in the tutorial sheet and submit to me on this tutorial sheet. It should be tutorial sheet 9. This should be tutorial sheet 9. Let me see. Yeah, tutorial sheet 9. On this tutorial sheet 9, solve all the questions and submit to me. Is that okay?
Yes, sir.
So,
Yes, sir. And sir,
yes.
hello?
Yes, I'm hearing you.
Yeah, sir. Just a request. Yeah, just a request, sir. When sending this record, sir, please try to convert it into PDF so that you send the PDF as well. Because some of us we don't have bundles which can watch this again. So try to convert it so that you send the PDF.
There is no PDF of a, there's no such thing as PDF of a video. I usually send you this one. What's this? This
The
PDF,
record.
the document. I send you the document. And how can the video be turned into a PDF? It's not possible. As in you have to read the video. How can you read the video? I usually send you this PDF document I'm using, and I sent it to you. So I think I'll send it again just for the sake of our friend who has joined us today. But there's no way you can have the video and in fact it's not going to consume a lot of bundles. You can on YouTube you can choose, there's a section where you can choose for using few bundles. So in fact this one, it is just going to take you maybe 15 MBs, 20 MBs maximum, also 20 MBs, which you can't fail to watch. So is that okay now?
All right.
So good.
Sir.
Have a good day. Yes.
Yeah, the request, I have a request.
Yes.
They have shifted the quiz to next week Friday because the topic is long and the questions seems they will be increased by 5. So I think that part where there is the buoyance, is it buoyance force? What I think we need to cut that maybe next.
Even that one, because that one is not on properties of matter, if I'm not mistaken. That is on density and volume, density and volume. I think
I think the quiz will go as far as that because he said the topic is too long than other topics. So the questions instead of 10 will be 15, and then I've given you even more time, 1 week more. So I think if it was this only, we would have written maybe this Friday.
Okay, let's do that. I have no problem with that. So still, have a good day then.
All right, thank you, sir.
Thank you. Good day.
Okay.